Here are your notes, 12-3, Introduction to Solving Quadratics. You're using the date 3/25 for Monday the 25th. A quadratic equation is a polynomial of degree 2. We graphed quadratic equations last week. And you know that it looks like a parabola or a U shape. A root is what we're going to find today. And a root is the value that makes an equation true. And the solution set are the numbers that are in the domain that make the sentence true. So it asks us for number 1 to put into standard form. So standard form is when it looks like y equals ax squared plus bx plus c, or if y is 0, and so we have ax squared plus bx plus c. So the first thing I want to do is clear parentheses, and I get x squared minus 4x equals 5. And I want the equation to equal 0, so I want to put the 5 over on the opposite side by subtracting both sides by 5 and getting 0. Now I can't subtract a 5, or there are no terms to combine with the 5 on the left-hand side, so I just write it out as x squared minus 4x minus 5 equals 0. And that's all they want us to do for number 1, is to put it into standard form. For example number 2, they're asking us to solve for the values of x. So there are multiple roots where the value of x is equal to 0. So we're going to factor this polynomial, this quadratic, into 2 binomials before we solve for x. Now, I know the only way I can get the first term is x times x is how I get x squared. How do I get a positive 2? Well, I can do 1 times 2, or I can do negative 1 times negative 2. And then I say, okay, which of those terms adds up to get me the middle term of negative 3x? And now I have to think of, okay, I'm not multiplying anymore, I'm just adding, and it's a negative 1 and a negative 2. So if I go back and check these 2 binomials, I have the first term, which is x times x, x squared, the outside terms, which is negative 2x, then the inside, and then the last. So it does check out to be the original. And so now I must be able to solve for the values of x. So I have on one side the parentheses x minus 1 equals 0. And on the opposite side, I'm going to have x minus 2 also equal to 0, because I'm trying to find a value for x that works when this equation is equal to 0. So how do I solve this one-step equation? I add 1 to both sides. So at x equals 1, the graph of this quadratic is going to cross at the ordered pair 1, 0. And over here on the opposite side, I solve. And the graph of this quadratic, if I were to graph this x squared minus 3x plus 2, I would get another point at 2, 0. These are called the roots. This and this are called the roots. And the solution set is when we use the special brackets, the squiggly brackets, we would have 1, comma 2, and that's just another way to write it. That's the solution set. This right here is the solution set. So let's try that again. I don't think that you should at this point do anything on your own. I think you should follow along with me again. So I have this not equal to 0. It's like the example number 1 where I have to put it into standard form in order to find the roots. So I'm going to add 10 to both sides to get it into standard form, which means I need it to equal 0. I have x squared minus 7x plus 10. And now I need to factor. And so how do I get x squared? That's x times x. How do I get positive 10? What are the factors of positive 10? I have 1 times 10. I have negative 1 times negative 10. I have 2 times 5. And I have negative 2 times negative 5. Those are all my factors of 10. That's the two numbers that multiply to get 10. So then I look at the middle term, and the middle term is how we add to get that term. And the only way I can add to get that term is a negative 2 and a negative 5. So those are my two binomials. And now I am going to set each of them equal to 0 in order to find the root, or the roots. And so I add 2 to both sides for x minus 2. And I get x is equal to positive 2. And I'm going to add 5 to both sides for the x minus 5. And I get x is equal to 5. So my solution set is the set 2, comma 5 with squiggly brackets. Those are the two roots, or the two values that identify the solution set. And the place where this graph is going to have ordered pairs specifically on x squared minus 7x plus 10 is at 2, 0 and 5, 0. These are kind of like the x-intercepts. It's where they cross the x-axis. So here's a Regents practice question. It says, what is the solution set of the equation 3x squared equals 48? Well, the first thing I need to do is to always have it equal 0. I always have to start off with it equaling 0, and if it doesn't, then I have to put it in standard form so that it does. So I'm going to subtract 48 from both sides, and then I have to worry about my factoring and being good at factoring. And I think that it has a greatest common factor here. If I take out a 3, I am left with x squared minus 16, because 3 times x squared is 3x squared, and 3 times a minus 16 is minus 48. And now I can factor this. I can, since I have the difference of perfect squares. X squared is a perfect square, it's x times x, and minus 16 is minus 4 times positive 4. And that would mean that the middle term would cancel out. That was the perfect squares factoring, or reverse FOIL. And so the 3 gets ignored because there is no x term. And so the only two that you have to worry about solving for are the x minus 4 equals 0 and the x plus 4 equals 0. And so we add 4 to both sides here and get x is equal to 4. And we subtract 4 from both sides here to get x is equal to negative 4. So the values we're looking for are negative 4 and 4, which is the solution set here, choice D. Regents review number 2 says, what is the solution set of m squared minus 3m minus 10 equals 0? So we don't have to put it into standard form. It's already done for us. We do need to factor it. M times m is m squared. The factors of negative 10 are negative 1 and 10, 1 and negative 10, negative 2 and 5, and 2 and negative 5. We have to have opposite signs. Which of those two add up to give me a negative 3? That would be the plus 2 minus 5. And I have two terms here. M plus 2 equals 0. m minus 5 equals 0. And so I'm going to solve for m this time for my roots and for my solution set. And I get negative 2 and positive 5. And choice D, negative 2, positive 5. Number 3, solve for x. So we're doing the exact same thing. Every single time they're just kind of asking us to do something different. Solve for x, find the roots, find the solution set, all meaning the same thing. It means factor it and set them equal to 0. So what are the factors of negative 24? There's quite a few. We have negative 1 and 24, 1 and negative 24. We have negative 2 and 12, 2 and negative 12. We have negative 3 and 8, 3 and negative 8. We're trying to find the one that's going to add up to this middle term of positive 2. Have we come across that yet? No. Negative 4, positive 6, 4, and negative 6. And we're looking for a positive 2, and I think I have found my match. It's x minus 4, x plus 6. And I'm going to solve for x for both of these terms. Plus 4 to both sides, x equals positive 4, and x equals negative 6. So they found the values for x. We found that it's x equals 4, x equals negative 6. You can stop there, but just a reminder, if they ask for the solution set, you are looking to write it with the squiggly brackets. If they're asking for the roots or where it crosses the x-axis, you're writing it as 4, 0 and negative 6, 0. So that's solving quadratics. We're going to take a couple days going over and reviewing this and practicing and doing examples. Have a good night.